All right, everybody, we are going to switch over to quantitative variables now for a bit. Um, so we had been working with our categorical variables. We formatted them and made these frequency distributions. And just as a reminder, when we were doing the data management, we did go ahead and do the data management for the quantitative variables. That's done right here. We changed the variable names into diagnosis, age, and sibling number, um, and then we took out all the values that really we couldn't do the analysis for. So the code is kind of a one-liner to make a histogram, um, and very difficult, at least for me, to memorize. So I have it in my clipboard. So I'm going to paste that in here. And the first thing I want folks to notice is we're using the Seaborn package for the very first time. So when we load all these packages, we've used pandas a lot every time we say PD, like when we read in the data set, we used pandas package, and we used research.py when we made the frequency distributions. Well, now we're going to use Seaborn. So make sure that Seaborn is imported. Otherwise, it's not going to work. It's going to give you an error. Okay, so histplot is the function name from the Seaborn package, and you put the variable name with a dot, and then all this stuff, and then a semicolon. And so I'm going to go over a couple of these and what they're about, and the rest of them we'll just leave the way they are and call it a day. So here's the histogram. Notice it puts the variable name down here, and because the statistic that I wanted to measure here was percent, it's putting percent on this side. The bin width is how wide each of these bars are. So basically it looks through at the diagnosis age, and anyone that was diagnosed as a baby, little under 3%. Diagnosed as a 1-year-old, a little over 8%. Diagnosed as a 2-year-old, about 4 point something percent. So each of these bars corresponds to an age. If I change the bin width to say 2, now it's going to lump 2 ages together. So infants and 1-year-olds put together, and they total about 11%, something like that. And you can make the bin width, kind of whatever you want. And what you're going to do is limit the detail that you see. The wider the bin width, the more data is in there. You don't know actually where it is. In fact, when we go back to 1, there was this bimodal picture here. We saw that 1-year-olds, and it looks like 12-year-olds, are kind of tied as the most frequent age to get diagnosed with asthma, and you lose that when you go through. It just looks like it gets less and less and less and less as you go down. Kind of like skewed right a little bit looking over here. So it's always a judgment call what looks best to you. In this particular case, I liked 1. It kind of, there aren't that many ages here, so you can still kind of parse out what's going on here. And it does have a little bit of a skewed right feel to it, but mostly I would highlight that it's bimodal, that really there's these 2 ages that stand out as the most frequent. This percent, if instead we put frequency, then it's just going to tell us the counts over here as opposed to the percents. And so it's very similar to what we saw on these frequency distributions for the categorical variable, that you have access to the count, but then the inside they also can calculate a percent for you. I kind of like percent on this, so I'm going to switch it back to percent. Okay, so I am going to do the same thing for my other variable. So I'm going to go up here and remind myself that the other variable is sibling number. And so I can even copy and paste that. over here. And I'm going to leave all this the same. And what do we see? Classic skewed right. So when we think about, most people have one or two or maybe three brothers and sisters, three siblings, but still you got some people with 8 siblings or 12 siblings or 20 siblings, but it gets less and less frequent. Another common instance out in the world where you get this skewed right feel, that you just, the further out to the right you get, you still have data, but really less and less and less, is stuff like income, that most people make is, within a certain amount, but then there are some folks that make a lot more than the rest of us make. Okay, so this is a pretty short video. We got both of those in and a little bit of a discussion about histograms. All right, see you later.